We know that the force a single charge experiences if it moves with a velocity v in the region of a uniform magnetic field is just given by the cross product between its velocity vector and the magnetic field vector at a given point, multiplied with the charge carried by the particle itself. How about the force experienced by a current-carrying conductor? Experimentally, we find if we place a conductor in a region of uniform magnetic field and we drive a current through the conductor deforms as if being pulled by a force to one side. If we reverse the direction of the current, we find that the conductor is deformed as if being pulled to the opposite side, which implies that there must be a force acting on a conductor carrying a current. We can derive an expression for this from our microscopic description of the current, where we know that the current in a conductor is defined in terms of the number of charge carriers per unit volume multiplied by the volume itself, multiplied by the charge each charge carrier carries. If we take the time derivative of this expression, we just end up with the current in terms of a drift speed. If we assume that each charge carrier in the conductor has got a drift velocity equals to the drift speed in the direction of current flow, we can write the force that this charge will experience as a cross product between its velocity and the magnetic field multiplied by the charge it carries. In this case, the direction of the force is now determined by the direction of current flow cross with the magnetic field vector. If we add up all these contributions for the whole conductor, therefore, multiplying the expression for the force acting on a single charge by the amount of charges per unit volume and the volume of the conductor itself, we get the resultant force acting on the conductor. We can simplify this expression by substituting in the value for the current and defining a vector L equals to the length of the conductor pointing in the direction of current flow. Then we have that the magnetic force acting on a charge carrying conductor of length L is equals to the cross product between the vector L and the magnetic field multiplied by the current flowing through the conductor.